Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Sciences, SOS, Others Programs, Appreciation Course on Environment, ACE, Block-1 Environmental Concerns, Unit-4 Development and Environment Pollution, 4.1 Introduction. In this unit, pollution is the topic for discussion. Pollution is caused by any undesirable physical, biological or chemical change in the components of the environment, i.e., air, water and soil. In our daily usage, pollution implies the adverse state of environment we live in. In the preceding units you have studied about the concept of environment and Earth's resources available for meeting the basic requirements and developmental needs of ever-growing human population. Unmindful use of resources and energy-intensive technologies that generate lot of wastes have resulted in degraded and polluted environment. The adverse effects are on living systems including humans, buildings and other materials. Eventually, none of us can escape from direct or indirect encounters with pollutants, as pollution created in air, water or soil are ultimately bound to become global, i.e., spread throughout the biosphere as it has one continuous environment. In this unit you will study about the pollution in air, water and soil, their sources and their effects in brief. Apart from gaseous and other chemicals, noise, radiations and thermal pollution also have adverse effects on living organism and create problems of survival for humans and other living beings, though natural processes also affect the environment but at an extremely slow rate. The pollution we are going to study in this unit is generated at an accelerated rate as a result of our own activities. In the next unit you will study about the adverse effects of polluted environment on human health. Objectives: after studying this unit you should be able to times define pollution and pollutants, times identify and list major types of pollutants that contaminate our air, water and soil, times explain the critical importance of a temperature range for the living organisms, times comprehend and trace the pathways of major pollutants in the ecosystem, times enumerate the reasons for high noise levels in the urban areas, and times discuss the hazardous effects of radiations and the need for safeguards to prevent accidental release of radioactivity. 4.2 What is pollution? Most of us are aware of the term pollution. Pollution is defined as any undesirable change in the physical, chemical or biological characteristics of environmental components, i.e., air, water and soil that adversely affects the life forms and life support systems of the biosphere directly or indirectly. You can also say that pollution is unfavorable alteration of our environment, mainly due to human activities. The agent that contaminates the environmental component is called the pollutant. A normal constituent of the environment becomes pollutant if its concentration increases beyond the limits, destroying its usefulness. A pollutant is also a new substance, biotic or abiotic, or energy, heat, sound, radioactivity, etc., that is added to or formed in any component of the environment and builds up to a level where usefulness of that component is damaged. Pollutants can be grouped into two broad categories. Non-degradable pollutants. These remain in an unchanged form in the environment for a very long time, such as pesticides, heavy metals, rubber, nuclear wastes, etc. Plastics also fall in the same category. Such substances are not broken down or decomposed by bacteria. These pollutants persist for very long time in nature, get accumulated and often biomagnify to a dangerous level when they move in material cycles in the nature and along with the food chain. 2. Biodegradable pollutants. Pollutants such as paper, garden waste, domestic sewage, agro-based residues, and fertilizers etc. break down into simple products by bacterial decomposition process. These simple products are raw materials of nature that are reutilized in the ecosystem. Decomposition of these non-persistent pollutants occurs naturally as well as through engineered systems such as sewage treatment plant. Such man-made systems enhance nature's capacity to decompose. These biodegradable pollutants pose a threat when their input in the environment exceeds the decomposition capacity. Pollutants can enter the environment either through point or non-point sources. Point sources are distinct and confined sources that discharge the pollutants effluents through a chimney or through a discharge channel such as pipes or tunnels from industries or municipal areas. Non-point sources or area so times. CES are diffused sources that discharge pollutants over a large area. Some of the examples are runoffs from construction sites and agricultural fields. Pollutions emanating from the point sources can be controlled through on-site treatment. It is difficult to treat pollution arising from non-point sources because of its widely dispersed sources over a large area. Pollutants may have different kinds of effects on humans as well as on other components of biosphere. The reasons for this are the differences in the chemistry and concentrations of the pollutants. Another problem of pollutants is their synergic effect, which refers to the interaction of different substances where combined effect is greater than the sum of the effects of separate substances. For example, the air pollutants sulfur dioxide and particulates, when inhaled separately, may cause adverse health effects. But sulfur dioxide can be adsorbed on small particulates, and together both may be inhaled deeper and retained longer than sulfur dioxide alone and cause greater damage to the lungs. Another aspect of synergic effect is that the body may be more sensitive to a substance if is simultaneously exposed to other substances and stresses. 4.3 Build up of pollution in the environment. Since the Industrial Revolution, the most significant development in the human history, we have used our planet's resources including living organisms without the concern for the consequences of our actions. Industrial processes and pace of increase in human population led to the increase in the consumption of energy and natural resources. Growing use of the resources have ensured the steady rise in the emissions of gases, chemicals, wastes and other materials into air, water, soil and eventually in the biosphere. Resources and energy are required by humans for fulfilling their needs as well as greed for food, housing, transportation, entertainment, luxuries, etc. With ever-increasing human population, demand for resources and energy sources like wood, minerals, water, soil, coal, oil, gas, etc. increases. In Table 4.1 you can see how during last 50 years of industrialization there has been an increasing trend in the usage and build-up of resources that has affected the environment. Table 4.1 Increasing trend in the resource usage, build-ups and the effects on environment. Items concentrations in effect on 19501995 environment. Coal use 884 million tons 2083 million tons climate change oil equivalent. Oil production 518 million tons 2953 million tons climate change. Natural gas 180 million tons 2128 million tons climate change. Production oil equivalent. Fertilizer use 14 million tons 125 million tons water pollution. CFC production 42,000 tons 300,000 tons ozone layer depletion. Nuclear arsenal 304451000 global security. human 2.55 billion, more than 5.6 changed land use and population billion resource use patterns. Source: Vital Signs, 1995, WRI, of all the animal species, humans have incredible ability and capacity for adjusting to and manipulating the environment. Technologies have enabled us to overcome adversities of nature to a great extent so that we can live anywhere and work anywhere. Subsequently, explosion in human population, urbanization, deforestation, profit-oriented capitalism and technological advances have contributed to the pollution crisis. Our resource consumption, strategies and living styles have compelled us to live in a polluted environment, be it indoors or outdoors. The obvious reason for the presence of pollutants in our homes, offices and other indoor areas is that there are many potential indoor sources of pollution. Table 4.2. People spend considerable time by remaining indoors, therefore, the need is to understand its environment. Table 4.2. Some examples of usage sources that lead to indoor and outdoor pollution. Sources: pollutants, predominantly indoor, times particle board, foam insulation, furnishing, formaldehyde, ceiling tiles, tobacco smoke, times building materials, concrete, stone, water and radon, soil, times fireproofing, thermal and electrical insulation, asbestos, mineral wools, acoustic synthetic fibers, times adhesives, solvents, paints, varnishes, cooking, organic substances, nicotine, cosmetics, tobacco smoke. Aerosol, volatile organics, times pesticides in paints, spills in laboratories, mercury, cadmium, sprays, times consumer products, house dust, animal debris, aerosols of varying infected organisms composition. Allergens, viable microorganisms, dash 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 predominantal outdoor, times coal and oil combustion, smelters, fires, photochemical reactions, automobiles, smelters, soil particulates, industrial emissions, sulfur oxides, ozone, lead, manganese, calcium, chlorine, silicon, cadmium, organic substances, times petrochemical solvents, vaporization often bumped, fuels, indoor and outdoor, nitrogen oxides, carbon monoxide, carbon dioxide, suspended particulate matter, times fuel. Combustion, times incomplete fuel combustion, times fossil fuel combustion, metabolic activity, times resuspension, condensation of vapors, combustion products, times petroleum products, combustion. Paint, metabolic action, pesticides, insecticides, fungicides, times cleaning products, agriculture, metabolic, products, organic substances, heavy metals, ammonia. Today, technological developments and their applications have made life comfortable for most of the human beings. However, in the process, humans have moved away from nature, altered the environment and often short-sightedly or even recklessly damaged it. In the following sections you will read about what causes pollution in various environmental components. 4.4 AIR pollution. Has it ever occurred to you that air is as much a resource as water or food? 2. I stay alive. The average adult human being exchanges about 6 times more amount of gases per day as compared to daily consumption of food and water. This is the reason that air quality is important to us. In Unit 1 you have read about the composition of normal air. For most of the living beings, oxygen is the immediate requirement from the environment. We can live for days without food and water but only for few minutes without oxygen. Any significant change in the normal composition of air is harmful. Carbon dioxide is essential requirement in the environment for green plants to make their food. However, if its concentration increases beyond the limits, the air becomes polluted and toxic. 4.4.1 Types of air pollutants. Broadly, air pollutants can be categorized into following groups. 1. Natural pollutants. These pollutants are released from natural sources or as a result of natural activity. Some examples are pollens and volatile, organic compounds from plants, gases like sulfur dioxide, hydrogen, sulfide etc. from volcanic eruptions and decay of organic materials, particles from wildfires and sea, natural radioactivity etc. In general, natural emissions are low in concentrations and do not tend to cause serious damage. 2. Primary pollutants. These pollutants are emitted directly into the air as a result of natural or human activity. Examples include sulfur dioxide, nitrogen oxides, carbon dioxide, carbon monoxide, hydrocarbons, and particulates released from fuel burning. 3. Secondary pollutants. Secondary pollutants are produced as a result of chemical reactions between primary pollutants and normal atmospheric compounds under the influence of electromagnetic radiations from the sun. For example, the primary pollutant sulfur dioxide S02 reacts with oxygen 02 in the atmosphere to form sulfur trioxide S03, a secondary pollutant. Sulfur trioxide further reacts with water vapor to form another secondary pollutant sulfuric acid H2S04, which is a component of acid rain. Another example is the formation of ozone on a bright sunny day over the urban areas. Nitrogen dioxide N02 absorbs ultraviolet radiations that reach at the Earth's surface and split into nitrogen oxide No and oxygen atoms 0. These oxygen atoms which combine with oxygen molecules to form ozone 03. N02 also contributes in the formation of other secondary pollutants, peroxyacetyl nitrate, TAN, and nitric acid, HN03. Smog, a mixture of smoke and fog, is formed by complex reactions between oxides of nitrogen and a wide range of hydrocarbons triggered by sunlight. It is formed mostly in urban areas, especially in stagnant airs. The main reason is vehicular overpopulation. 4.4.2 Major air pollutants that are produced in significant amounts and adversely affect human health and the environment are major air pollutants. Every year over a billion metric tons of the pollutants are released into the atmosphere from human-related processes. If these pollutants were to be uniformly distributed the atmosphere, the concentration would be very little, a few parts per million ppm by weight. Big cities are polluted because of large population, industries, and weather conditions. Let us now study Table 4.3 to know about major air pollutants, their sources, and an overview of their effects on humans and the environment. Later in Unit 5 you will study about health problems in details. Table 4.3 Major air pollutants, their sources and their effects on humans and environment. Pollutants, sources of the effects, production, times oxides of carbon, combustion of coal, oil. CO2 has a major role in coks and other fuels for energy. Greenhouse effect, carbon dioxide, CO2 production, manufacturing produces weak carbonic, carbon monoxide and transport, biomass. Acid adding to acid rains, burning affects human health by binding to hemoglobin, which may result in asphyxia. Hemoglobin has 250 times more affinity with CO as compared to that of 0.2 times oxides of sulfur. Combustion of sulfur S02 has maximum SOx containing fuel. Example, coal, deleterious effects as it petroleum extraction and can cause severe damage. Sulfur dioxide S02, sulfur trioxide refining, paper to human and other animal S03, manufacturing, municipal lungs and is important. Sulfate, S04, incinerating, or a smelting precursor to acid rain. For metal extraction, adverse effects include corrosion of paints, metals, and injury or death to animals and plants. Times. Oxides of nitrogen, burning of fuels, biomass form the secondary NOx burning byproduct in the pollutants peroxyacetyl. Nitrogen oxide, no manufacturing of nitrate, TAN and nitric, nitrogen dioxide fertilizers acid, HN03, suppression, times N02 of plant growth and tissue, nitrous oxide, N20, damage, cause irritation to eyes, viral infections like nitrate, N03, influenza, nitrate form in atmosphere impairs the visibility whereas in soil promotes the plant growth. Hydrocarbons, HCs, evaporation from gasoline can have carcinogenic times, also called volatile tanks, carburetors, burning effect on humans, higher. Organic compounds of fuels, biomass, concentrations are toxic to VOCs, municipal landfills, plants and animals, can, methane, CH4, microbial activity of convert into harmful, butane, C4HIO, sewage, industrial process compounds through, involving solvents complex chemical, ethylene, C2H4, changes that occur in benzene, C6H6, atmosphere, some are benzopyrene, C2O12, more reactive with propane, C3HG, sun-GHT and produce photochemical smog times other organic aerosol sprays. Foam and CFCs cause reduction in compounds plastics for making stratospheric ozone that chlorofluorocarbons, disposable fast food allows greater penetration, CFCs, containers, refrigeration of ultraviolet light at formaldehyde, CH2O, Earth's surface, intensified methylene chloride, UV radiations cause skin, CH2CH, cancer and can have lethal effects on various life, trichloroethylene, C2HCH, forms, vinyl chloride, C2H3CI, carbon tetrachloride, CCI4, ethylene oxide, C2H4O, times metals and other. Oil wells and refineries cause respiratory, inorganic compounds transport vehicles, problems, toxicity and lead, Pb, mercury, Hg, municipal landfills, even death to humans and hydrogen sulfide, H2S. Fertilizer, ceramic, paper, other animals, damage to hydrogen fluoride, HF, chemical and paint crops, prove to be industries, pesticides, carcinogenic, fungicides, aluminium, production, coal, gasification, times, liquid droplets agricultural pesticides, contribute to acid rains, sulfuric acid, H2S04, fumigation, oil refineries, corrosion, damage to nitric acid, HN03, reactions of pollutants in various life forms, oil, the atmosphere, pesticides e.g. DDT and malathion, times, suspended particulate matter, SPM solid fuel combustion, building have chronic effects on particles, constructions, mining, respiratory system, dust, soil, sulfate salts. Thermal power stations, deposition on the surface, heavy metal salts, firestone crushing, industrial of green leaves thus, particles of carbon, soot, processes, forest fires, interfering with absorption, silica, asbestos, liquid, refuse incineration of CO2 and release of O2, sprays, mist etc., blocking of sunlight, particles size that range between 0.1 to 10 urn, cause greatest lung damage, times. Photochemical oxidants, photochemical reactions produce Haj, irritation to ozone. 03. Peroxyacyl in the atmosphere that eyes, nose and throat, nitrates, PANs, involve sunlight, oxides of respiratory problems, formaldehyde, CH2O, nitrogen and hydrocarbons blocking of sunlight. acetaldehyde C2-0, hydrogen peroxide H202, hydroxyl radical, BO 4.4.3 air pollution and atmospheric problems. Apart from causing damage to materials, plant and animal communities and health problems in humans, air pollution affects the atmospheric processes. Acid rain, smog, global warming, ozone depletion, etc. are some of the effects of pollution in our atmosphere. Let us look into some examples of the problems of air pollution in our atmosphere. Later in the course you will also read about pollution problems at global level. 1. Suspended particulate matter. Suspended particulate matter, SPM, consists solid and low vapor pressure, liquid particles that float around in the atmosphere and have size ranging between 0.01 micrometer to 100 SPM in the ambient air is complex and variable mixture of different sized particles with many chemical components. Larger particles come from industrial dust, volcanic particles, and plant pollens. Fine particles are formed by combustion processes. SPM in urban areas are mainly sulfates, carbon particles and polynuclear aromatic hydrocarbons, pus. Larger particles are trapped by nose hair, vibrissae, and breathing tubes. Particles smaller than 10 in size, known as PM10, are respirable suspended particulate matter, RSPM. Final particles of size less than 2.5 are known as PM2.5. They can be inhaled deep in the lungs and cause a lot of trouble. SPM can adversely affect the photosynthetic process in plants by covering the leaves and plugging the stomata. This reduces absorption of CO2 and sunlight. Study of ambient air quality of some Indian cities conducted by Central Pollution Control Board (CPCB) from January to April in the year 2002 showed that Kanpur had highest level of RSPM, Table 4.4. Table 4.4 RSPM levels in some Indian cities during the year 2002. Cities RSPM levels, micrograms per cubic meter, Kanpur 119 to 257, Delhi 147, Kolkata 55 to 129, Bangalore 65 to 119, Vadodara 84 to 119, Chennai 25 to 49. Standard level of RSPM is 60 micrograms per cubic meter. Ambient air quality monitored for annual concentrations of RSPM at IGNOU. Intersection, New Delhi from the year 1998 to 2000 showed that RSPM levels exceeded the standard levels. Modern day SPM problems are mainly due to industries and automobiles. Delhi has much more number of vehicles than in Mumbai, Kolkata and Chennai. Yet about hundreds of vehicles are being added to Delhi's roads every day. With this trend in 5 years, the number of vehicles on Delhi's road would be about 43 lakhs as compared to 2.17 lakhs in 1971. Trend analysis of air pollution up to the year 2000 in Delhi by CPCB showed high levels of CO, mainly due to vehicular population. SPM and RSPM levels also exceeded the National Ambient Air Quality Standards (NAQS) during these years. However, there was a decreasing trend in the levels of S02 and N02. The annual mean concentration of S02 did not exceed the NAQS annual average. This could be due to low sulfur diesel introduced in Delhi and prohibition from plying of commercial vehicles more than 15 years old in Delhi. The use of unleaded petrol has drastically lowered the level of lead, much below NAQS levels. Fly ash is the ash that floats out with hot air as a result of fuel burning for use in power plants or some other industries. The annual estimated generation of fly ash based on coal consumption data at various coal-based power plants at Delhi are shown in 2. Acid precipitation. Acid rain or acid precipitation includes wet acidic depositions like rain, snow, fog, mist or dew and deposition of dry acidic particulates from the air. Acid precipitation occurs in and around the areas where major emissions of sulfur dioxide SO2 and nitrogen oxides NOx occur as a result of anthropogenic activities. Hydrochloric acid emitted from coal-fired power plants RDDS to acid rain problems. Acid depositions have disastrous effects on the life forms as well as the materials. The pH of aquatic bodies is lowered, which may harm or kill their biota. pH is a numerical value to derive the strength of an acid or a base. A highly acidic solution will have quite low pH value. Neutral solution has pH 7. Soil fertility is adversely affected because acidic water in soil releases immobile heavy metal ions which are highly injurious to plants and other soil biota. It can also devoid the soil of its nutrients. Dry sulfate, nitrate and chloride particles also contribute in acidic deposition. These particles are converted to acids when they dissolve in surface water or contact moist tissues like in lungs or on moist leaf surfaces. Acid rain forms relatively higher in the atmosphere and travels long distance. Acid fog forms when water vapor near the ground mixes with pollutants and turns into an acid. When the fog eventually dissipates, nearly pure drops of acid may be left behind and tiny particles containing the acid may be inhaled deeply into people's lungs. Such acid aerosols are a human health hazard. Apart from damaging forests and lakes, acid rain corrodes and harms building materials such as steel, paints, plastics, cement, limestone, sandstone and marble. 3. Atmospheric inversion. Atmospheric or temperature inversion occurs when a stable layer of warmer air lays above the cooler air. The normal phenomenon of temperature decline along the increasing height reverses and thereby convection air currents that normally disperse the pollutants are prevented. An inverted temperature gradient occurs. Air circulations are restricted and pollutants are trapped in the lower atmosphere within the stagnant air mass. So temperature inversions prevent the pollutants from being transported by weather systems. Inverted temperature gradient occurs when cool air slides under warmer air mass or cool air subsides down a mountain slope and displaces warmer air in the valley below. When a cloud cover associated with the stagnant air mass develops over an urban area, the incoming solar radiation is blocked by the clouds. The air on the ground, Earth's surface, cools, and if there is enough humidity, the air is cooled further, and when dew point, water condensation, temperature, reaches a thick fog may form. The pollutants delivered in the atmosphere keep on accumulating and building up till the stagnant conditions exist. However, the inversions are usually not stable. The sun, heat and winds tend to break up the gradient and mix air layer. Urban areas tend to exhibit heat island profile as they are warmer than the surrounding areas. This heat island effect is due to increased heat production resulting from burning of fossil fuels and industrial and residential activities. Also, there is a decrease in the heat loss due to the abundance of buildings and paving materials made of dark materials that absorb the sun's rays rather than reflecting them away. These cause the temperature of surfaces and air surrounding the surfaces to rise. Another contributory factor is fewer number of plantations in the urban areas. Trees shrubs and other plants can intercept solar radiations and cool the air by the evapotranspiration process. In 1969, as part of its global empire, Union Carbide Corporation set up its pesticide formulation unit in the northern end of the city of Bhopal in central India. Initially, it mixed and packaged imported pesticides, but later expanded. In December 1979, its methyl isocyanate (MIC) plant with an installed capacity of 5,000 tons went into production. On the night of 2nd December 1984, during routine maintenance operations in the plant, at about 9.30 p.m., a large quantity of water-carrying catalytic material entered methyl isocyanate (MIC) storage tank number 610. In the early hours of 3rd December, 40 tons of toxic gases were released from the plant as a result of contamination of the storage tank and spread throughout the city. The one insult was a nightmare that still has not ended. No alarm ever sounded a warning and no evacuation plan was prepared. The gas leak lasted less than 1 hour, yet the accident killed about 2,500 people. About 100,000 were seriously injured by the gas, which causes bumps on contact, severe irritation to eyes, nose, throat and lungs. Only a few ppm of inhaled gas causes violent coughing, swelling of lungs, bleeding and death. Exposure to lower concentrations causes problems like loss of sight. Investigations, however, revealed that before the tragedy there had not been a single year when some mishap had not occurred. On various occasions, inquiries were ordered and subsequently forgotten. This showed that there was something wrong in the safety standards. A 3-member safety team from the Union Carbide headquarters in America visited the Bhopal plant in May 1982 and submitted a report on the defects in the safety standards in the MIC section. Among the deficiencies in the safety standards which aided in the tragedy, some of the crucial ones are as follows. 1. The devices used for measuring the changes in temperature and pressure in the various units of the industry, including the MIC storage tanks, were so poorly maintained that the workers got used to ignoring even the early signals of trouble. 2. The refrigeration plant that was used for keeping the MIC storage tank at low temperatures so as to minimize overheating and expansion even when a contaminant like water gets into the tank had been shut off for some time. 3. The gas scrubber intended to neutralize the escaping MIC, even though it was inefficiently designed for the purpose, was also shut off for the maintenance. This scrubber was designed to handle about 25% of the MIC that could escape at maximum pressure. 4. The flame tower intended to bomb the MIC gas that escaped from the gas scrubber was also shut down for the replacement of a corrosive pipe. Even this flame tower, as designed to handle only about 1/4 of the volume of MIC gas, released. Some of the findings of ICMR on the health status of the persons who directly or indirectly suffered by the exposure are as follows: times fibrosis of the lungs, neurotic depression, anxiety and psychosis was reported in 22.6% of exposed people. Times studies from 1987 to 89 show that gas-exposed children up to age 5 years at the time of disaster suffered 2 to 4 times more from fever, breathlessness, vomiting and cough compared to children among similar unexposed populations. Times as late as in 1990, spontaneous abortion rates among the exposed women were more than 3 times than that among unexposed women. The sufferings can be minimized and deaths can be avoided if the locals, industrial workers, and health personnel are educated about the nature of chemicals, their toxicity, levels of risks, and the methods of handling them. It is The utter failure of both internal and external workforce and the machinery that causes deaths and sufferings of this magnitude. Underscore 4.5 Water pollution. Any physical, biological or chemical change that degrades the water quality results in water pollution. Water being a universal solvent can dissolve various types of substances in it. For this property, contamination of water becomes inevitable. On evaporation, water becomes purified, but when it falls back on earth as rainwater, it picks up soluble gases, particulates, etc. on its way. Polluted water is a threat to our health and survival of aquatic life and other life. Forms. The pollution in non-flowing water bodies like ponds, lakes and underground water becomes localized and confined, making it more serious. The major human-generated sources of water pollution are sewage, garbage and refuse, industrial and agricultural wastes like fertilizers and pesticides. Generally, a water body has the capacity to absorb or break down pollutants, but if the influx of substances exceeds the capacity, water body becomes polluted. Shows the routine human activities that contribute to water pollution. 4.5.1 Types of water pollutants. Water pollutants are divided into following major categories. The types, sources and effects of water polluting agents shown in Table 4. 5 are sometimes interrelated. 1. Biological agents. Pathogenic organisms like viruses, bacteria and protozoans are serious water pollutants as far as human health is concerned. Cholera, bacterial and amoebic, dysentery, gastroenteritis, typhoid, polio, viral hepatitis, worm infections, flu, etc. are important waterborne diseases. Some insects that have aquatic larvae transmit malaria, dengue, yellow fever and filariasis. In our country generally, onset of rainy season is accompanied by such epidemics. Floods, water, logging, pipe bursting, mixing of sewage water with drinking water are some of the common problems we face during rainy season that cause these epidemics. Overpopulated areas. Unplanned industrial and human settlements, lack of proper civic amenities are some of the contributory factors. Water gets contaminated due to human wastes, animal wastes, domestic sewage and wastewater discharges from tanneries and slaughterhouses. 2. Chemical agents. Chemical pollutants can be water-soluble, water-insoluble or oxygen-demanding wastes. These can be inorganic in nature like nitrates, phosphates, acids, salts and toxic heavy metals. Organic chemical pollutants include oil, gasoline, pesticides, dyes, paints, plastics, cleaning solvents, detergents and organic wastes like domestic sewage, animal waste, etc. Radioactive substances that make the third category of chemical pollutants are released into water bodies as a result of processing of uranium ore, wastes from research laboratories, etc. Later in this unit you will read about radioactive pollution, organic wastes and inorganic nutrients like phosphates and nitrates enrich the water bodies that may cause eutrophication. Inorganic salts ionize in water, enrich it and also render hardness to it. Chemicals like acids, alkalis, detergents, bleaching agents are released from various industries. The effects in water bodies include color changes of water. Iron oxide gives red color and iron sulfate gives yellow color, forming by detergents, etc. Such changes are not harmful to the organisms dependent on these water bodies. 3. Physical agents. Suspended solids, sedimentary solids and temperature are the physical factors that affect the quality of water. These water pollutants adversely affect by silting, clogging the waterways, filling the dams and making the water muddy. Aquatic animals face problems in breathing through gills in such waters. Suspended organic and mineral solids adsorb toxic substances like heavy metals and pass them in food chain. Thermal pollution occurs when heat-laden water enters the water body. You will read about thermal pollution later in this section. Pollutants, Table 4.5 Major water pollutants, their sources and their effects. Biological agents, bacteria, parasitic fungi and protozoa, chemical agents, inorganic chemicals and minerals, acids, salts, metals like lead and mercury, plant, nutrients like phosphates and nitrates, organic chemicals, pesticides, herbicides, detergents, chlorine, compounds, oil, grease and plastics, radioactive substances, physical agents, particulates and heat sources, human sewage, animal and plant wastes, decaying organic matter, industrial wastes, oil refineries, paper mill, food processing units. Natural, land and urban runoffs, natural runoff from land, urban storm, industrial wastes, acid deposition, leaded gasoline, lead, smelting, irrigation, pesticides, agricultural runoffs, mining, oil fields, domestic sewage, inadequate wastewater treatment, food processing, industries, detergents containing phosphates, agriculture, forestry, pest control industries, home and industrial wastes, water disinfection processes, paper industry, bleaching process, machine and pipeline wastes, oil spills, home, community and industrial use. Nuclear wastes from research laboratories and hospitals, processing of uranium ore, nuclear plants. Soil erosion, runoffs from the agriculture, mining, forestry and construction activities, power plants, industrial cooling, oxygen requiring bacteria feed on these biological wastes and deplete oxygen. In the water body, life is destroyed in absence of oxygen, foul odors, poisoned livestock, toxic to various life forms and humans through food chain, can cause genetic and birth defects, increased solubility of harmful minerals in water, make water unfit for domestic, agricultural and industrial uses, salinity, build up in soil, upsets times, ecosystem of water bodies and cause eutrophication, toxic to aquatic life forms, as well as organisms that depend on such water bodies. Eutrophication of water bodies, radionuclides enter the food chain and cause birth and genetic defects, causative agent for cancer, filling of waterways, harbors and reservoirs. Increase in temperature lowers the solubility of oxygen in water, reduction in biotic life in the water bodies. The types, sources and effects of water pollutants are often interrelated. However, for discussions they can be divided into TWS major categories as causative agents of problems of human health as well as ecosystems as a whole, as shown in Table 4.6. Table 4.6 Categories of water pollutants. Pollutant category examples: I. Human health problems. 1. Infectious agents. Bacteria, viruses, parasites. 2. Inorganic chemicals, acids, caustics, salts, metals. 3. Organic chemicals, pesticides, detergents, oil, gasoline. 4. Radioactive material, uranium, thorium, cesium. Iodine, radon. 11. Ecosystem disruption. 1. Oxygen-demanding wastes, plant and animal residues and manures. 2. Plant nutrients, nitrates, phosphates. 3. Sediments, soil, silt. 4. Thermal heat. All segments of our society, urban, rural, industrial, agricultural, may contribute to water pollution problems. Various processes and materials pollute the fresh water bodies, the surface water and groundwater. Table 4.7. Most of the sources of groundwater pollution result from runoffs, leaks or seepage. of pollutants, Table 4.7, some sources of surface water and groundwater pollution, surface water sources, groundwater sources, times urban runoff, urban settlements, times leaks from waste disposal sites. Industrial areas, chemicals, radioactive material, etc., times agricultural runoff, oil, metals, industrial, pesticides, etc. J. Agricultural areas times leaks from buried tanks and pipes, times accidental spills of chemicals, gasoline, oil, etc. Industrial, urban, rural, industrial, agricultural, times leaks from surface storage tanks or times seepage from agricultural activities, pipelines, gasoline, oil, etc. Nitrates, heavy metals, pesticides, industrial, agricultural herbicide, etc. Agricultural, times runoff, solvents, chemical, etc. times seepage from septic systems, rural, industrial sites like factories, times seepage from acid-rich water from refineries, mines, etc. Mines and mine waste piles, industrial, times radioactive materials, accident, times seepage of pesticides, herbicides, industrial nutrients, etc. Urban, times sediments from agricultural lands, times seepage from accidental spills, construction sites, etc. Urban, rural, industrial, agricultural, times seepage of solvents, detergents and times air fallout in rivers, lakes, oceans, other chemicals, radioactive material, particles, pesticides, metals, etc. from big industrial and small scale. Urban, rural, industrial, agricultural, industrial sites, etc. Urban, industrial, times salt water infusion into coastal aquifers, urban, rural, industrial. 4.5.2 State of Indian water resources. Majority of Indian rivers are in the state of polluted drains today. Betwa, Bhadar, Bhavani, Cheliyar, Damodar, Noyal, Sabarmati and Yamuna are few examples. CPCB is monitoring the water quality of water resources at various locations in the country. These locations include stations on rivers, lakes, canals, drains, ponds and groundwater sources. The water quality monitoring results obtained during 2002 indicate that surface waters in terms of the length of rivers have different levels of pollution. The water quality results were analyzed with respect to BOD, i.e., oxygen-consuming demands of microorganisms, bacteria and fecal coliform present in these water sources. BOD values greater than 6 mg per liter indicated high. Pollution levels of water. Moderately polluted river waters have BOD values between 3 to 6 mg per I. Waters having BOD less than 3 mg1 are relatively clean. Major sources of pollution in Indian aquatic resources are urban liquid wastes, consisting of untreated sewage and sludge waste, industrial liquid wastes, bathing of cattle, dead bodies, surface runoffs from agricultural areas, solid waste landfills and dump sites filled with municipal and industrial wastes, heavy metals like cadmium, zinc, nickel, lead, chromium and copper are concentrated in the surface waters and sediments and in groundwaters. Organic pollutants in water may lead to epidemics like cholera, gastroenteritis, and typhoid. Heavy metals may have lethal impact on human health if enter the food chain. For example, cadmium is a potent kidney toxicant and mercury is a potent neurological toxicant. CPCB.T. Report shy levels of zinc and nickel in the sediments of Yamuna River downstream from Delhi. A large percentage of wastewater and of BOD load is released into the river daily from New Delhi. In fact, about 2% of total length of Yamuna accounts for most of its pollution. In Kanpur, hazardous toxics such as arsenic, cadmium, mercury, nickel and chromium have been detected in Ganga waters and at an alarming level in underground waters. Levels of organic pollutants are also high. Tannery. Other industrial effluents and municipal wastes are contributors. Religious activities like immersions and mass bathing substantially increase the amount of dissolved solids, heavy metals. 4.5.3 Eutrophication, addition of phosphates, nitrates and organic wastes from industries like tanneries, slaughterhouses, starch factories, paper mills, milk plants, runoffs from agricultural lands irrigate water bodies by increasing their nutrient content and so increase their productivity. The productivity of an ecosystem reflects the rate at which its producers photosynthesize. A lake with high productivity is called an eutrophic lake as it has a dense population of producers often visible as green scum on the surface water. The activities of aerobic bacteria, the I-composers, in the presence of oxygen release the nutrients from the organic wastes. These nutrients act as fertilizers and cause population explosion of water microscopic plants like algae and others like duckweed, water hyacinth, etc. The abundant growth of algae is called algal bloom. Bacterial activity consumes lot of dissolved oxygen and so do the algae and other green plants for respiration. This leads to decrease in the oxygen available to fishes that ultimately causes the death of the fishes. The chemical cycle and ecosystem of the water body changes. Fig. 4.12. In due course of time the water body diminishes and eventually disappears. However, eutrophication occurs only in stagnant water bodies and not in flowing water, because flowing water carries away the wastes and the nutrients and disperses it to larger area. An oligotrophic lake has low nutrient content, low productivity and clear water that could be drinkable. 4.5.4 Marine pollution. Oceans are the ultimate sink of pollutants that are either directly dumped in the form of wastes or reach there as runoffs through streams, canals or rivers or accidental spills like oil spill. Major pollution of marine waters occurs near the coastlines where large cities, harbors and industrial centers are situated. The pollution of oceans, seas, estuaries, salt marshes and other similar water bodies is called as marine or ocean pollution. About 25% of the Takhtal Indian population lives in coastal areas and dependent on marine resources. The kind of pollutants encountered here are sewage, municipal discharge, agricultural, runoffs, sludge, industrial effluents, waste heat generated from industries during cooling processes, oil spills and discharge from marine vessels, oil and grease discharge from shipping industry and accidental discharge of oil from tankers. About 210 million gallons of petroleum enter the seas world over each year as a result of extraction, transportation, and consumption of oil and its products. About 180 million gallons of oil come into seas annually from natural seepage. Of the annual gush of the petroleum into the seas, oil spills account for about 8% while oil drilling and extraction contribute about 3%. Sealed containers packed with waste containing poisonous chemicals, radioactive isotopes, etc. are dumped into the sea. These drums are sometimes not properly packed or dropped at the right place in the ocean. Sooner or later, these drums tend to leak or break off. After an oil spill, the aromatic hydrocarbons that are low boiling are the primary cause of immediate killing of number of aquatic organisms, especially in their larval forms. However, it is fortunate that most of these toxic substances evaporate into the atmosphere within a day or two. Some other types of chemicals in the oil remain floating on the surface. These floating oil tilde and coat the feathers of marine birds. especially diving birds and few of marine mammals such as seals and others. This all coating destroys the animal's natural insulation and buoyancy, and most of them drown or die of exposure from loss of body heat. It is estimated that few lakh marine birds in the North Sea and North Atlantic regions are killed each year by chronic oil pollution. The floating substances are gradually broken down by bacteria over the period of several weeks or months, though they persist for much longer time in cold polar waters. All types of pollutants affect the marine life forms adversely. The non-biodegradable pollutants biologically magnify in the marine organism, which may ultimately reach the human body. 4.5.5 Thermal pollution. Thermal pollution occurs when the temperatures of a water body or air in the atmosphere are raised or lowered and subsequently deviate from normal levels. Water temperatures are normally more stable than the air temperatures, so aquatic organisms are generally not adapted to rapid and sudden temperature changes. If the temperature of tropical oceans is lowered by even 1 degree, the environment can become lethal to some corals and some reef species. Raising the water temperature can have similar effects on sensitive organisms. Thermal pollution occurs when waste heat is released into a water body. Natural causes such as forest fires and volcanoes release the sudden heat into the environment. Human causes of thermal pollution are altering of vegetation cover as well as the arcing of heated water from steam generators, metal smelters, processing mills, petroleum refineries, paper mills, food processing factories and chemical manufacturing plants use water for cooling purposes. Eventually this water gets heated and is released as effluent from the industrial units. Subsequently, the release of heated water into a water body changes its temperature as well as concentration of dissolved oxygen in the water body T. Because oxygen is less soluble in warm waters, every species survives within optimal range of temperature. For some, like certain fish species, this range is small and so a slight change in water temperature can cause problems. For example, lake fishes move away when water temperature rises more than 5 degrees C above normal, whereas river fish can withstand a rise of the temperature by 3 degrees Celsius. Fig. 4.13. Warmer water may cause stress in the fishes and they may become easier for predators to catch. The change of temperature also changes the conditions for other life forms available in the aquatic body. All this may subsequently result in the changes in the biota of such aquatic bodies. The solutions to the problem of chronic thermal pollution lies in retaining the heated water and effluents discharged by the power plants and other industrial unit in a holding unit and be cooled prior to their discharge into the water body. Waste heat generated from industries can be alternatively used for purposes like warming the buildings in colder seasons. 4.5.6 Water quality parameters. There are several parameters applied to assess the quality of water. Water samples are tested for these parameters to ensure that water is fit for consumption. Dissolved oxygen, DO, biological oxygen demand, BOD, chemical oxygen demand, COD, most probable number, MPN, and total dissolved solids, TDS, are some such parameters. 1. Dissolved oxygen, DO, it refers to the amount of oxygen gas, 0.2, that is dissolved into the water of any water source. Higher amounts of dissolved oxygen indicate that water quality is good. Low concentrations of oxygen content in the water indicate the presence of organic waste pollutant in water. 2. Biological oxygen demand, BOD. BOD is a measure of oxygen used by microorganisms such as bacteria to decompose the organic matter like sewage, dead plant leaves, grass blades and food wastes. If the amount of organic wastes is high in the water source, more bacteria will be present to consume oxygen. Under such polluted conditions, demand for oxygen will be high and so the BOD values will be high. With high levels of BOD, levels of DO in the water decrease. 3. Chemical oxygen demand, COD, it is the amount of oxygen required to degrade or break down the organic, chemical compounds of wastewater. A water body that receives effluents from chemical industries shows high values of COD. 4. Most probable number, MPN, the water polluted with organic wastes such as sewage sludge will have high population of bacteria like E. coli and coliforms. With the help of MPN test, both E. coli and coliforms can be detected and enumerated. MPN method statistically predicts the number of these organisms present in the water body. Coliform is present in human intestines and isn't necessarily harmful to us. But its presence indicates the presence of human waste in the water. Polluted water will show high values of MPN. 5. Total dissolved solids, TDS. The amount of salts and solids dissolved in water is measured by testing the TDS and salinity contents. Some of the dissolved substances that make the water quality poor are calcium, phosphorus, iron sulfates, carbonates, nitrates, chlorides, and other salts. Heavy metals also fall in this category. Excessive amounts of TDS degrade the quality of water. 4.6 Soil pollution. All the terrestrial organisms including us interact directly with the surface layer, offland i.e., soil as it provides us the basic necessities of life, food, shelter and clothing. The vital source, soil, is only 6 inches deep on the land surface throughout. Apart from natural causes, we, the human population, contribute to the degradation of our land surface mainly by 3 ways: by using it, agricultural and developmental activities, by taking things out of it, mining and deforestation, by putting things into it, waste disposal. The major fallout of our overindulgence with our land areas are as follows. 1. Loss of biodiversity. Natural flora and fauna are destroyed due to cutting of vast areas of forests as land is required to fulfill the agricultural and developmental needs, desires and greed of ever-growing populations of humans. According to International Union for Conservation of Nature, IUCN, it is estimated that by the year 2050, up to 50,000 plant species will become extinct or threatened. Presently, about 4,500 animal species and 20,000 plant species are considered by the scientists to be threatened. 2. Soil erosion. It is the process of loosening, detachment and removal of soil components, especially the topsoil particles. Soil erosion is caused by wind blows and water flows. But these forces can act only if the land surface becomes devoid of vegetation cover. Excessive loss of topsoil reduces soil fertility and results into deposition of eroded soil in the riverbeds, i.e., silting of water bodies. 3. Acidity and alkalinity. Increase in the acidic or alkaline content of the soil reduces its fertility and is not good for certain types of crops. The soil becomes acidic when hydrogen ion concentration of the soil is increased. Minerals like calcium carbonate and alkaline compounds tend to get deposited in the soil if the climate is dry or rainfall is low. This increases the alkalinity of soil. Unmindful use of land and wrong agricultural practices are the main human-generated reasons for such state of soil. 4. Land pollution by waste deposition. We can call our land area as an ultimate garbage can as waste generated, mainly by human activities, is dumped in it as well as buried in it. The major types of wastes and their sources are listed in Table 4.8. Waste disposal is one of the major problems, and per capita waste generation in India is on increasing trend. As in other Asian countries, in India most of the solid waste is landfilled. The wastes are largely dumped, and the practices are not in keeping with modern requirements of sanitary landfills. All types of waste is dumped in the landfills, and when water seeps through them it gets contaminated and in turn pollutes the surrounding areas. This contamination of soil and groundwater through landfills is known as leaching. The uncovered, untreated and unsegregated solid wastes are also left in open dumps. The rainwater runoff from such dump sites contaminates nearby land and water body. The ash obtained after burning wastes in the incinerators may contain high concentration of dangerous toxins such as dioxins and heavy metals. When buried in the landfills, this ash leaches in the surrounding area and causes pollution. The pollutants once enter any component of the biosphere, ecosphere, can cycle through all the components, i.e. air, water and soil, and can enter the organisms. Fig. 4.14. Let us take the example of pesticides, the chemicals that are used to eliminate the pests. For use in the fields, pesticides are dusted or sprayed on plants or else mixed in the soil of the fields. Spraying and evaporation enable the entry of pesticides in the atmosphere. Rainfalls bring back these chemicals to land area and water bodies. Runoffs from agricultural lands bring the pesticides into the water bodies. Irrigation from such water bodies takes back pesticides in the field areas. Pesticides in the soil and water may again evaporate into the air. Persistent chemicals and pollutants follow this pathway for much longer time and enter the food chain. If not biodegradable, these pollutants can bioaccumulate and biomagnify in the higher levels of food chain. Fig. 4.15. Bioaccumulation refers to the entry of a pollutant in a food chain. It is the increase in the concentration of a pollutant from the environment to the first organism in the food chain. Biomagnification is the phenomenon of increase in the concentration of a pollutant from one link in a food chain to another. However, life of biodegradable polluting agents is much less and they can be broken down before they become dangerous. The pollutants that are soluble in water can be excreted by the organism. Fat-soluble pollutants may be retained for a long time and biomagnify. Fatty tissues of organisms such as fishes are tested for the detection and measurement of such pollutants. In mammals, often mother's milk is tested for the pollutants since it has a lot of fat in it. 4.7. Noise pollution. Sound is the medium for communication. It is almost impossible to lead our day-to-day life without sound. However, sound is annoying and harmful if it becomes noise. Noise is any unwanted or exceedingly high levels of sound that can annoy, cause stress or impair the hearing ability. Increased use of technology has added to noise pollution. The main sources of noise are industrial operations, machines, vehicles, railways, aircrafts, military arms and ammunition, construction work and household appliances. In fact, if we look around, we will find that noise is most widespread occupational hazard when we are on roads, on our duties and also at home. Sound travels in the form of waves. The waves exert pressure. Loudness or the intensity of the sound is measured by measuring the pressure on a 7 scale called decibel, dB. A 10-fold increase in the sound intensity is represented as 10 decibels on scale. The instrument is called decibel meter. Apart from pressure, sound has pitch also. A high-pitched sound is louder than low-pitched sound even if the pressure is same. Also, high-pitched sound is more annoying than low-pitched sound of same intensity. The unit that measures both pressure and pitch of the sound is called decibel, dBA. Noise can affect by interfering with communication, causing health and behavior disorders and diminishing the hearing. Increased adrenaline levels, hypertension, migraine, high cholesterol levels, gastric ulcers, easy irritability, insomnia, increased aggressive behavior and other psychological disorders and permanent damage to hearing ability may be caused in humans by high sound levels. You can see in Able 4.9 noise levels of different sounds on decibel scale and some of their effects on humans. Noise pollution control measures include I. Reduction of noise at source, 2. Interruptions in the path of transmission, and 3. Protection of the receiver. Comparatively little attention has been paid to control noise pollution in our country. Awareness, motivation, legislations and their effective implementations are required to control the menace of noise pollution. Monitoring of ambient noise levels by CPCB on Deepavali day at certain locations in Delhi showed that noise levels were much higher than the prescribed limits of 45 dBA during night time applicable to residential area. In 1998 it ranged between 66.0 dBA and 103.0 dBA, whereas in 1999 it was found between 66.1 dBA and 84.4 dBA. Initiative of school children against the use of cracker for Deepavali celebrations can contribute in the control of noise and air pollution. Lower levels of ambient noise have been reported at various locations during Deepavali festivals in the years 2000 and 2001. Apart from rise in noise levels due to firing of crackers, air pollution levels in terms of sulfur dioxide, oxides of nitrogen, carbon monoxide and suspended particulate matter shoot up on Deepavali day and further deteriorate the quality of ambient air. 4.8 Pollution by radioactivity. Radiation is the inherent character of all types of matter and atoms. It is the phenomenon of propagation of energy in the form of fast-moving particles or waves through matter or space. These moving particles are called particulate radiations and waves are called electromagnetic waves or radiations. All types of the radiations are the form of energy. Radiations that have longer wavelengths have low frequency, low energy and less penetrating power. Radiations with shorter wavelengths have high frequency, high energy and high penetrating power. Radioisotopes are the forms of chemical elements whose nuclei spontaneously emit high-energy electromagnetic radiation or particulate radiation while gradually changing from one form to another. Table 4.10. Radioisotopes are also called radionuclides. This property of radioactive decay of elements is called radioactivity. There are three major types of nuclear radiations: I. Positively charged alpha A particles, 2. Negatively charged beta tilde particles and 3. Gamma Y rays that are without any charge. Neutron particles are also released by some radioactive atoms. These particles do not have the charge but are capable of traveling through the material. UV rays and X-rays are another kind of radiations. The penetrating power of these radiations vary. Fig. 4.16 Gamma rays, X-rays and neutrons are extremely energetic and need concrete or lead shielding to block their passage. Beta particles can penetrate the skin region. Alpha particles have least penetrating power, and can be stopped by a sheet of paper. Alterations in the biomolecules alter the cells that may die or function abnormally, eventually leading to chronic health problems. If the effects are not severe, the person may show signs of allergy, asthma, minor muscular or bone defects, hypertension, or certain minor genetic aberrations. Severe effects include cancers and genetic defects that pass on to next generations. Skin cancer is mostly caused by UV rays. Depletion in stratospheric ozone increases the dosage of UV radiations reaching on Earth and thus increased risks of skin cancer. If exposure to radiations is for a short time, exposed cells in the body can possibly recover after some time. But if the exposure is for a long time, the recovery mechanisms of cells may not be enough to revert the damage. This is the reason why a person should not go for T90 many X-rays. We can be exposed to atomic radiations every day from natural as well as man-made sources. Cosmic rays from space provide about 1/2 of natural background radiations. Other natural sources include radioactive rocks and soils. Human sources also contribute significantly. Use of X-rays for medical diagnostic purposes, radioisotopes for research activities, and power and energy generation by nuclear reactors are major usage of radioactivity by humans. The production of radioactive material before its use requires the processes of mining, milling, and processing. You can see in figure 4.19 how the utilization of radioactive material in a nuclear reactor requires a number of prior steps that lead to the generation of nuclear waste. Radioactive wastes are byproducts that must be expected when electricity is produced in the nuclear reactors. In addition, the ore tailings obtained during the mining of uranium are also hazardous. It is important to safely dispose of or store these wastes. Normal practice is to store radioactive wastes underground. The site is carefully selected to avoid the movement of such wastes within the ground or across other environment interfaces, air and water. The technology related to safety measures to operate nuclear reactors on paper appear quite safe. However, accidental toxic radioactive release from time to time has taken place from such facilities. Events at 3 Mile Island and Chemobil have resulted in the problems of radiation pollution. 156 Case study, 3 Mile Island. The 3 Mile Island power plant is near Harrisburg, Pennsylvania in USA. It had two pressurized water reactors. The accident happened in the second unit at 4 am on 28 March 1979. Malfunctions of the nuclear plant resulted in a release of radioisotopes into the environment as well as intense radiation release within one of the nuclear facilities. The emissions were estimated to be low in terms of amount of radiation required to cause acute toxic effects. However, radiatory levels were much higher near the site. It became clear with this accident that there are many potential problems with the way our society deals with nuclear power. Historically, nuclear power had been safer and state of Pennsylvania was unprepared to deal with the accident. In the power plant, the operators were unable to diagnose and respond properly to the unplanned automatic shutdown of the reactor. Deficient control room instrumentation and inadequate emergency response training also proved to be the causes of the accident. Also, there was no State Bureau for Radiation Health and State Department of Health did not have reference material on radiation medicine. The major impact of the accident was fear. Since the long-term effects of exposure to low doses of radiations are not well understood, it is difficult to estimate the after effects of 3 Mile Island exposure. The longer-term impacts of this accident have been an application of the accident lessons to produce important, continuing improvement in the performance of all nuclear power plants and a better understanding of fuel melting. Few years later, a major nuclear plant accident occurred at Chernobyl, about which you will read in Unit 11.4.10 summary. In this unit you have read about the concept of pollution and pollutants of air, water and soil resulting from human activities. Environmental degradation also occurs due to noise and radioactive pollution. Times pollutants are the agents that cause undesirable changes in the quality of air, water and soil. Anthropogenic activities are primarily responsible for pollution and environmental degradation. The natures of pollutants largely depend on factors like our lifestyle, occupation, habits, traditions and awareness etc. Times unmindful use of resources, byproducts of industrial processes, waste generation, lack of will on the part of people to treat and manage the effluents and wastes are the contributory factors in polluting the environments. Biodegradable pollutants break down easily, but non-degradable pollutants, when introduced in any component of the ecosystem, can cycle through all the environmental components, i.e. air, water and soil. Times in the ecosystem, pollutants affect the humans and other life forms directly or indirectly by causing damage to materials and crops. Persistent pollutants such as heavy metals and persistent organic compound enter the food chain, get biomagnified at the higher levels of food chain and eventually reach the human beings, causing a variety of health problems. Public awareness of the causes and problems caused by pollution and active involvement of individuals and communities, apart from strict environment law and their strict implementations, are essential to control environmental pollution. Use of eco-friendly technologies are highly effective in combating the problem of pollution caused by industry. In the following units you will study about the health problems caused by pollution and the rectifying measures that are taken or can be taken to restore a healthy and sustainable environment. Thank you. Subscribe to our channel for more updates and we will see you with the next chapter.